Hi guys, so in this video we'll be looking at perpendicular lines, okay, and how we find the equation of perpendicular lines and how we solve or prove whether two lines are perpendicular or not. So something you need to know, okay, perpendicular lines intersect at right angles, okay, so they do intersect compared to parallel lines, just so we go back to that. So parallel lines don't intersect, perpendicular lines do intersect, and they intersect at right angles or 90 degrees. So just this diagram on the right over here, you can see we've got two lines, okay, with two different gradients, and they intersect at right angles. Okay, and secondly, what you should know is both the gradients multiplied should equal -1. And you can write it in terms of an equation, okay, in books they write it as equations or formulas. So one way of writing it is m1 times m2, where these two are the gradients, should equal -1. So both the gradients multiplied equals -1. And some other books that write it like this as well, as m1 equals -1 over m2, where it is a negative reciprocal, okay, to each other, okay. So it's a negative reciprocal. When I use the word reciprocal, I'm saying the opposite, so as a fraction, okay. So that's what I mean by reciprocal, okay, putting it as a fraction and opposite fraction. Okay, so this is a negative reciprocal. We'll go over an example and see how it is done, right? So what we'll do is we'll look at proving whether this equation over here is perpendicular to this equation over here. Okay, and how do we prove it? Well, we just have to find both the gradients and see whether it satisfies one of these conditions over here. Okay, either one. Cool. So we know the gradient over here is -3. Okay, we found that right there. Cool, because this is already written as y equals mx plus c form. We found our gradient. But for this equation over here, we have to rearrange. Cool. So let's rearrange to make y the subject. Okay, so what I'll do is I'll leave -9y as it is, and I'll have 15 minus 3x. Then I'll have to divide this by -9, divide this side by -9 as well, so I go -9 over there, and -9 over there. And I should get y equals, so that if I can simplify that, so 15 over -9, I can divide both of them by 3, so that becomes 5, or -5 over 3. Okay, or not -3, sorry, just simplify it. Okay, take 3 out as a common factor, so we get plus x over 3. And we find out our gradient in this situation, because we got the x over there, is positive 1 over 3. Equation, okay, of a perpendicular line. Okay, so we're going to look at finding the equation of a line that goes through the coordinate point 3 and 1. Okay, so that line passes through that point, and it has to be perpendicular to the equation 2x plus y equals 2. Okay, so we're finding an equation that goes through this point 3 and 1, and it's perpendicular to the equation 2x plus y equals 2. So first things first, let's go find the gradient of this equation over here. It's pretty simple rearranging, so we got y equals 2 minus 2x. And we have determined the gradient for this equation is -2. Therefore, the gradient we want for our equation, so I'll write that as m1, we want m2 to be the reciprocal of that. Okay, therefore we want that to be 1/2. And I'll just do it in yellow over here so you can see what I mean. So we've got -2 times m2 equals -1. And then that's the equation I'm using. m1 times m2 equals -1. I'll divide this side by -2, divide this side by -2, therefore m2 equals positive 1/2. And that is what I have determined right there. Cool, and now I'll just go to my equation, my general straight line equation of y minus y1 equals m bracket x minus x1. Okay, I'll use this equation because I've got a coordinate point and I have got the gradient. And now I substitute in the missing values of y1, m, and x1. So y minus 1 equals 1/2 over x minus 3. And I'll expand it out and determine what my equation is. Y minus 1 is equal to 1/2 x minus 3 over 2. Cool. Take the negative 1 across, so you've got y equals 1/2 x minus 3 over 2 plus 1. Well, I know I can write 1 as a fraction. 1 is also known as 2 over 2 because I want to have the same denominator. Y is equal to 1/2 x minus 3 over 2 plus 2 over 2, and therefore I have found the equation to be y is equal to 1/2 x minus 1/2. Cool, and that's the equation that is perpendicular to this equation right here. Okay, hopefully that comes up. Oh, there we go. So this is perpendicular to that equation right there. Okay, or that equation over there, whatever one you like. Okay, because we have satisfied that negative 2 times 1/2 is equal to negative 1. Okay, we've satisfied that condition, and we have just determined that this equation is perpendicular to that, and it passes through the point 3 and 1. Cool, so hopefully that helps, guys, and now you can find equations of perpendicular lines and also prove whether lines are perpendicular or not.